Now the application to be developed is fire alarm system to be fabricated on printer circuit board. The first objective is to design the circuit using software, and second is to fabricate the PCB board for the required application. Now coming to the purpose, the fire alarm system ensures the detection of fire, smoke or heat and to alert the surroundings. Now coming to the circuit diagram of fire alarm system, here we have 10 kilo ohms thermistor as a major component, which is an heat sensing devices that senses heat or smoke, which is connected to active devices like diode and transistor, which are used for switching operations. This 1 kilo ohm resistor which is connected in series with diode to the thermistor, which forms the voltage divider circuit with respect to the transistor. Now the thermistor at room temperature will offer 10 kilo ohms resistance initially, and when it senses heat or smoke, the resistance drops, and now the transistor switches the circuit and the buzzer goes on now. Now based on the heat senses, the buzzer turns on. Let's discuss on a PCB fabrication process for the fire alarm system. And here I have highlighted 4 simple steps. One is design process, second one is printing process, third is etching process, and fourth one is fabrication process. Coming to the first process of design process, so here we design the circuit by means of softwares like Eagle, Express PCB, or by means of RTM software. The second one is printing process. In this, the designed circuit supposed to be printed on a copper sheet by means of heating process. So here the design circuit will be printed on the copper sheet by means of heating process. And coming to the third process, that is etching process. This is the copper removal process. From the above printed copper sheet, other than the printed tracks, the copper is supposed to be removed, and this is done using ferric chloride solution dipped in water. And the final process is fabrication process. Here we do the complete fabrication by means of drilling and soldering. Step 1 is design process. Here we design the circuit using a dedicated software called Eagle. Now let us get into the design software. And now when the design is concerned, we should have a system with dedicated software, and the fabrication is done using manual soldering method. Now you can find the Eagle software shortcut icon on desktop. Now I am opening now. You can find the Eagle software from Autodesk. It is getting opened. And this is the main window of the Eagle software, that is the control panel that will let us know different menus, that is file, view, option, windows, help. So in the beginning it is good enough to note this listed one, that is file, new, project, schematic, board, libraries, and remaining all those. And in the beginning level it is very important to know each of these options, like control panel that will let us know all the menus, followed by schematic, board, and library. So schematic is the area where we draw the circuit, where we design the circuit by making use of all the components to be placed. And the board view will let us know the physical connection. So this is very important to know the physical connections between the components. And library has the predefined inbuilt functions and other component details. Now let us begin with the schematic with our project is concerned. And when you open the schematic, schematic window, so we will be getting the design window, the schematic area where we need to design our circuit with various options. And before to that, let me highlight you the circuit diagram of our application, that is fire alarm detection, already been discussed. So here we have that is important components like diode, transistor with respect to other resistors, active and passive components with respect to a supply and ground, and also a speaker or buzzer. So all these components are supposed to be selected from the libraries, and it has to be connected properly in schematic area. Now it is very important to know in the left side section, that is, we have certain things like move option where you can move the components, a rotate option for rotating the components, and first one is add parts. From this you can select all the components usage. So now here I am going with this add parts. So from the circuit diagram we have noted that we will be using resistor, transistor, diodes, all those. So in add parts you can find the search option over here where you can type the component names, say for example resistor. So once you hit the OK button, so you will be listed with the library functions. So here we are selecting European standard of any means of the specification. So that will let us know the figure out of the particular components what we are using. So here I am selecting in such a way of, that is 5 mm 0.2 inches of resistor. So I am making use of the OK button to get selected. So if I place over here, that is like a pick and drop, you can add as many as resistor you want. So we will be using 1, 2 resistor. Similarly, again we will be getting into add parts. For transistor we will be using BC547 transistor. So here it is listed with a different transistor name. So it's still, if we mention as BC547 as a standard transistor, if we search as BC547, it will be listed in the menus. You can select over this. Yes, here we are finding the NPN transistor. Click OK option. So we will be getting the transistor. And similarly other parts like thermistor and speakers, instead of selecting that one, let us have a jumper section where we are directly placing the components when we are soldering that. So it is good enough to take jumper, add parts in the search option, the search column. Let's type jumper. So where we can find jumper over here. So this jumper is of different that is physical structure. So it depends upon our leads, we are selecting the jumper unit. So I am making use of this one. Yes, now I am selecting different jumpers. So this is how we selected the components from the add parts, that is menu, where we selected all the necessary components what we are using for our application circuit. And now next thing is we need to ensure the connections. So connections, it is made by that is net, the option called net. If we click that, any components whatever we want to interface, it can be connected like this. So just click and just place it in the next device. Similarly you have to connect two resistors, so in such a way we can ensure the connection. So in the schematic window, it is very important to note down these options like add parts, move option, that will ensure you the proper moving of your components like this. press escape to leave the option, and rotate to rotate the particular component, and net for the connections between the components. Now once when the physical components and interconnections are made, it is good enough to save our project, and we need to switch to the board view. So from schematic we need to switch to the board view. Now our board view gets appeared. So this will let us know the physical connection between the components, and here we can note the layer setting in the top left corner. So we have three options like a preset bottom, standard and top. So this standard option let us both the components as well as the physical connection, and if we are making use of preset top, the components gets appear, and preset bottom will let us know the physical connection that is below the board, bottom of the board. And once when this is done, you can save that, and we can go for printing option. So here we have print option. It can be saved as a PDF file. So the designed one appears as a PDF file, and we have provisions like alignment, so top, right, center, bottom, in order to make use of the single photo sheet for a different design. So let it be top, right. I'm making use of from the one corner of the photo sheet. So if I press OK, and by minimizing this, our design appears as a PDF file. So we need to take a printout of this using a photo sheet, and we have to get ready for the next process. It is all about printing the design on copper sheet. Step 2 is printing process. Here we print the design circuit on copper sheet by means of any heating process like making use of an iron box. Let us get into the live picture. In printing process, we need to take the printout of the design on a photo sheet, and it is made to cut into small piece depending upon the size of the copper sheet. And now our task is to print the design on the copper sheet. So this can be made by placing the design above the copper sheet, and we have to ensure adequate heating process. So this can be done using a normal iron box. Now I am applying necessary heat on the copper sheet. So until the photo sheet is properly sticked on the surface of the copper sheet, we need to ensure adequate heating supply. Step 3 is etching process. This is the copper removal process from the previous printing process. Apart from the printed tracks, the remaining copper is supposed to be removed, and this is done using ferric chloride solution dipping in water, and this will ensure us the printed tracks gets appeared on the final board, and all the remaining copper gets disappeared.
After heating the copper sheet alongside with the photo sheet using iron box, we need to dip it inside the water in order to make the tracks to appear on the copper sheet. Now I am dipping the sheet inside the water. The tray should have sufficient amount of water. Now the designed sheet gets transferred to the copper sheet. The tracks gets appeared on the copper sheet. By dipping inside water, now we can notice the designed track gets appeared on the copper sheet. The etching process is a copper removal process. Here we need to remove the remaining copper other than the printed tracks, and this is done using dipping the same board on the tray of water alongside with the ferric chloride solution So this will make the copper to be removed other than the printed tracks. Now the ferric chloride is applied inside the tray of water.
Step 4 is fabrication process, and this is the final process. Here we place the components by means of drilling first, and then we'll go with final soldering. In fabrication process, let me go with the drilling first to place the components on the PCB board, and then with final soldering. Here I am doing a manual drilling process by placing the drill bit on the hole provision. So manual drilling is carried out. Once drilling is over, now the components can be placed on the board and it is meant for final soldering. So this is the appearance of the printed tracks on the copper sheet. This is the bottom surface and this is the top surface. Here the components gets appeared on the top surface, and in the bottom surface that gives us the physical connection between the components. And now let us choose the components like transistor, buzzer over here, and the thermistor and the remaining resistors. Now let us do final soldering. And this is the final fabricated PCB board of fire alarm system application, and this is the top surface. Here we can find all the components on the top surface, that is starting from thermistor unit, and we have other active devices like diode and transistor, and with other supporting resistor which forms the voltage divider circuit. And this is the buzzer, the output device. So based on the heat or smoke sensed by the thermistor, we will have that is alerting system, alarm system, by the switching process of transistor. And let me show you the bottom surface. And this is the bottom surface of the PCB board. This shows the physical connection between all the components. Let's go with the final testing of fire alarm system. Let me spark some fire near to the thermistor.